All right, we're going to go ahead and continue on with antennas. The antenna types and drags. All right, this is some of the newer figures that have been included with FAA exams showing us different types of antennas. I can't say we've got 100% good answers for these, but let's go ahead and give them a try. There's also the portion on drag. Drag, as we talked about before, is part of the maintenance AC, the part 2 alterations. And since technically if you're adding an antenna, you are adding to the load factor. And there's a table in the AC, as you can see, mostly looking at G forces, gravity pulling on an object. This is the standard problem that you'll see. It's somewhat tied into what we just saw, but this is the equation. And the equation is actually given. D, which is going to be the drag. What's the approximate drag load on an antenna with a frontal area A, of 0.125 square feet, installed on an aircraft with a speed, which is velocity squared, of 225 miles per hour. So basically we just go through the calculation. And I probably should have a calculator with me. What I usually like to do is the square first, the 225 times itself, or 225 squared. And you'll get a fairly large number, 50,625. Multiply that by area, 0.125 times 0.125. See, now we're down to about 6,300. All right, and then the final multiplication is times 0.000327. So that's going to knock the 6,300 down quite a bit ways. It'll take it down to 2.06929. It looks like it would agree with answer A. So basically you work through the formula. Figure 15. All right, there's two problems that'll go on figure 15. What's the approximate drag load on an antenna with the frontal area installed on an aircraft with a speed of? All right, so they're not even changing the problem around. So we basically start with our velocity, 275 squared, or times itself. We're up to a figure around 75,000. Multiply it by the area, 0.137. Drops us down to about 10,000. And now we're going to take our final multiplication against the factor given, 0.000327. Which gives us a drag load of 3.3879. Yeah, they should have. Well, it's gonna. The answer is gonna be A. I'm just surprised they didn't round it up. All right, those are the drag problems. You basically be prepared to work the formula. We're not going to necessarily give you the same numbers on the practice exams. So there's no just memorizing the correct answer. All right, here's the series of antennas. And I have worked this out to be a project, an in-class project where you actually fill out on a sheet of paper the variety of antennas. All right, so this first antenna, without even actually looking at the options, what does this initially look like? Well, you see it's a blade, so it's going to be a vertically polarized antenna. So that eliminates the VOR and the localizer. Glide slope, that was going to be that's also a horizontal, the one that looks like a tongue. So it's got to be radar beacon transponder, which it looks a number of transponders will look not always like this, but this can be a radar beacon transponder antenna, mostly by eliminating the other two. All right, next one. It looks like it's going to be bottom mounted, and I can see the little arrow, which usually indicates the direction of flight. What's this antenna used for? A, it's an altitude encoder used with transponders. Or a TCAS receiver used with monitoring and alerting systems. Or C, it's an aircraft radar beacon transponder used for location identification. Well, just because it was the answer of the last one, I'm going to eliminate C, but it's also that clearly doesn't look like one of our transponder antennas. All right, so that would leave altitude encoder used with transponders or a TCAS receiver. I'll basically review your antennas. If this one comes up, maybe this is one that you should just pretty much remember. It does look a little bit like an altitude encoder. I guess you can refer to it as an antenna. A little tricky. A TCAS receiver. All right, they're asking what the antenna is, not. I think just by elimination, I'm going to go with the altitude encoder. Okay, it is an altitude encoder used to convert the aircraft's pressure altitude into a code sent by the transponder to ATC. Yeah, this one's an obscure one, so hopefully you don't see figure 23. Figure 22, what type of antenna is this? Is that glide slope? Or is it does appear to be horizontally oriented, polarized. Or is it a DME or radar beacon transponder? Or is it a loop and sense antenna? I like loop and sense the best so far. Again, they might have me jump on the DME, but they had this radar beacon transponder again, so I'm going to go with loop and sense. 22, that is a loop and sense. It's a low-profile single antenna, and it is used for ADF, not DME. And what type of antenna is this? It looks like a double pole or a dipole antenna. It does appear to be in a horizontal polarity configuration, so more than likely it's going to be A, the glide slope. VOR, glide slope. Don't like that part of it. B, a marker beacon receiver antenna. No, that's usually just a little extra fairing on the bottom of the aircraft. Or C, a radar beacon transponder antenna. They definitely like using that as an option. I guess I'm going to have to go with VOR glide slope. It's not exactly looking like that, but I guess that could be it. Yes, it is. Whoops. What kind of antenna is this? Is that a VOR glide slope? Is it a marker beacon receiver antenna? I'm just going to say no on that right away. Well, actually, that's the next one, the radar beacon transponder. I'd like to say no to. The marker beacon, it's just if it had a more flush type profile, it doesn't need to extend that far. And I'm not sure why they're including the duplexer or the splitter. I guess I'm also going with VOR glide slope, even though that's not traditionally what it looks like. It certainly could be one. Yeah, these are a little tricky here. So, figure 26. Where is the strongest signal for this antenna? Is it below the antenna? Well, you can see in this area. Above the antenna in this area. Ahead of the antenna. Well, the three, mostly because of the way it is curved or bent. I would say it's the strongest signal is going to be below the antenna. Oh, okay, I got that one wrong. The strongest signals come from or are received at 30 degrees to the length of the antenna. There is no field generated off the end of the antenna. Okay. There you go. I'm not going to get 100%. Well, maybe now that I've reviewed, I would. And what type of antenna is this? Finally, it looks like the radar beacon transponder. Of course, they're not showing us that. The ELT, transmitter, emergency locator. Yes, that's going to be it. Is it a DME? A DME works a little bit on the same mechanisms or as the VOR. So that's not going to be what a DME antenna looks like. How about a VHF communications antenna? You know, if it was just a fin, I might go for that, but this is clearly the ELT antenna. That probably came with the unit. And what type of antenna is this? Is it a boomerang? A dipole? A Marconi? Or a loop? Well, you can see it's not a loop. Marconi is usually the quarter wave, vertically polarized, similar to what we just saw with in the prior illustration. Or is it a dipole? Well, you can see two in effect extensions of the antenna. So I'm going to go with the dipole. It's a V-shaped VOR navigation antenna, which is a common dipole antenna. And what kind of antenna is this? All right, it's a angled back. So what is this? A dipole? No. You would have to have, in effect, two poles. A canted antenna, I believe that is the word when they're angled back like that. Or a Marconi antenna. Not a terrible answer, but Marconi is not usually angled like that. So I'm going to say canted, which I believe is the correct verb for this type of antenna. Yes, many antennas are canted or slanted. Yeah, that wouldn't have been the right answer because everybody would take it. It's a slanted antenna for better reception. All right, we're not doing too bad. I know we're not getting 100, but this is usually usually a little tougher than it looks. Okay, here's another one. I can tell you right away it looks like a VOR antenna, but let's see. What kind of antenna is this? Glide slope? B, VOR and localizer? I like that, as you already know. Or C, a radar beacon transponder antenna? No. All right. The boomerang, the VOR. And since these are similar frequencies, they basically share the same antenna as the VOR and the localizer. What kind of antenna is this? Again, this could be mounted underneath the aircraft, and that would be more of the marker beacons. Excuse me. Which is one of our options. Lightning detector, no, that one has some holes in it. A satellite weather, that's the round. Usually it moves on a gyroscopic type control, and no, this is just a very simple horizontally polarized marker beacon receiver antenna. B. All right, this could also be our ELT, but let's see what the options are. What kind of antenna is this? Figure 32. A, the lightning detector. No, look for the holes for lightning. B, a marker beacon receiver antenna. That was what we just saw in the last one, which does not look similar, does it? Or C, a radar beacon transponder antenna. So, process of elimination also. I'm going to say it's the transponder. All right, here's one that has holes in it. So what type of antenna is that? A lightning detector system antenna. B, VOR localizer? Absolutely not, so process of elimination. Satellite weather antenna? Also process elimination. So two different ways you could get to it. Eliminate B and C, or just kind of recall that the lightning detector antenna has these holes in it. The storm scope. And figure 16, we've already seen it in two of the prior questions. We saw it number 2, which was our glide slope. And we may have seen 4. Of course, 3, our boomerang is going to be our VOR localizer. 1 and 4, they could be a number of things. But certainly one of them is the VHS or VHF communication system. And I believe the other one is DME. Let's see if I have a list of them here. All right. Yes, one is the DME, or the radar beacon transponder, since it's facing down. 2 is the glide slope, which is a question in of its own. 3 is the VOR localizer. And then 4 is the VHF communication antenna. Good. All right. Thanks for hanging in, and I'll see you on the next one.